Congratulations, you've officially made it to the end of Unit 1 of our Semester 2. Now, today we're going to start our practice test. If you were with us last semester, you know how this goes. If you're new with us, we spend 2 days on every practice test review at the end of every unit, and they are always 12 questions. So we'll spend today working on the first 6 questions, and in the next recording, you can find numbers 7 through 12, and all of that together is your practice test review. And remember, these questions are very similar to your Part 1 test. They're also going to help you with your Part 2 test. We're not going to do a Part 2 test review, and that is a TGA, but keep in mind, if you've understood and practiced and learned everything from this unit, especially in this review, then you will be good to go on that Part 2 test. Here's a few more details on this test. Remember, it's open notes, so you can have this with you. I encourage you to have it with you to help you. And just for completing this practice test, you will get 10 points. It's somewhere on here, not sure where. But all together over the semester, practice tests are worth 10% of your grade. That's the difference between an A and a B and a C, and so on. So watch the video, get the notes, practice it, get your practice test points, and also your unit test scores up. This unit, like I mentioned, you're going to have a Part 1 and a Part 2 test. Part 1 is computer graded, so you'll get that score automatically. It's 12 questions worth 3 points each for a total of 36 points. And the Part 2 test is a handwritten assignment. We call those TGAs, and that's 27 points. So if you do the math, you have 10 points for the practice test, plus 36 for the Part 1 and 27 for the Part 2. This adds up to quite a bit of points. So please take it seriously, and please make sure you do it. We're going to start with number 1. For every problem, I encourage you to pause and practice and then check your work. Because ultimately, keep in mind, this is review, meaning you've learned this before or should have learned this before. We've gone over it, and now it's time to practice. So here we go. Number 1, what's the minimum value for the function shown in the graph? Label it on the graph. This is a very simple question. Minimums are the lowest y value of any point. So ultimately, you're looking on your graph line and you're asking yourself, what's the very lowest point? It's right there. And if it's there, it's in the same place here. So we're looking at the y value there, okay? And that is 1. So the minimum value is 1. Number 2. Graph a sine function whose amplitude is 3, period is pi, midline is y equals -2, and y-intercept at 0, -2. The graph is not a reflection of the parent function over the x-axis. Let's break it down piece by piece. What's the first thing we always graph? The midline. So let's do it. Let's look through here for midline. Midline is y equals -2. Midline is a line. A line has an equation. Let's draw it and label it. Midline is done, so I'm going to underline it. And let's make that look a little better. Okay, what do we do next? Well, we want to graph the y-intercept next. And that has to do with, is it sine or cosine, positive or negative? Let's see. They told us right here it is a sine function. So we know the y-intercept is at the midline. Okay, but do we start by going up or down? Well, that all depends. Is it positive or negative? If it's positive, we go up. If it's a negative, we go down, right? Well, what did they say here in the end? They said the graph is not a reflection of the parent over the x-axis. Well, this parent function is positive, right? And positive goes up. So it's going to look something like this. We know we're going to go mid to mid, but we're not exactly sure how long the period is yet. Okay, so we know the general shape of the graph. We could draw it there if you'd like. but we need to figure out where that final point is. And that's all about the period length. So they tell us the period is pi. That's very nice of them to give us that information straight up. So when you travel over a time of pi, you go from midline to mid, mid to mid, right? And we know if you go mid to mid, there's also a point halfway in between. So we can graph that point as well. We also know it's going to go like this. So should we graph it yet? Not quite, because we don't know how high up, how steep. Are these really steep highs and lows, or are they more gradual like this? We still don't know. That's all about the vertical stretches and compressions. So let's see what they say. They tell us amplitude is 3. So that means distance from the midline to the max is 3. And midline to the min is 3. So every time you go over by our spacer, which we haven't found yet, in this graph it's a little more obvious that this is just evenly spaced out. So you'll go over pi over 4, you'll go up 3 over pi over 4, down 3, over pi over 4, down 3, over pi over 4, up 3. Now we can connect these dots. Did they ask us to graph one period or more? Let's see. They did not say to graph anymore. So that's done. And we didn't need to find the spacer here, but just so you remember, the spacer and amplitude combined are what we use to find, I'm going to say to plot the three middle points, or inner, I guess we should say inner points. So we're talking about this one, this one, this one. So we always start with the midline, then the y-intercept, then the point at the end of the first period, and then the three inner points. So to find your spacer, ultimately what you're doing is you're taking your period, which is from here to here, and you're dividing it into fours. 1, 2, 3, and 4. Fours. So for that reason, we divide the period by 4 to find our spacer. So we call it S for spacer. That's period divided by 4. Our period is pi. So there it is. Every time you go over pi over 4, you go up or down by the amplitude. Now, how do you know if you go up or down? Based off the behavior of the graph. This is positive sine, negative sine, positive cosine, negative cosine, with the y-intercepts all being on the left-hand side. Let's continue. The graph of f of x equals cosine of x. So this is the parent cosine function. And they're telling us it's transformed to a new function we're going to call g of x by reflecting it over the x-axis, stretching it horizontally by a factor of 3, and shifting it 4 units down. So there are several different transformations happening. What's the equation of the new function, g of x? Show and explain how to find a, b, and m. There are helpful guiding words on the board. Use those to help you complete this function. And now let's do it together. We know it's a cosine function because we're told right here, f of x equals cosine of x. Great. And it's negative because it is a reflection over the x-axis. They told us that right here, reflecting it over the x-axis. It's stretching horizontally by a factor of 3. So remember, if it's stretching by a factor of 3, that means b is the reciprocal of that. This is counterintuitive, so make sure you maybe highlight that part. Okay? And here's some more information on b to help you understand what's going on there. It's also shifting down 4 units, which means, well, that means the midline and everything moves down, right? That's what we talked about in class as the metal bar. You just pick it up and move it. Nothing's stretching, okay? So midline is y equals -4. The max and min are unknown. At this point, they didn't tell us, but that's okay. And we know A is 1 because we weren't told of any changes to amplitude. So the new function is what you see here. G of x is negative cosine x, so amplitude is 1, invisible 1 there. There's your B and your M. Now I'm going to quickly revisit B here because this is possibly the most confusing part of all of this. B tells you if there's a horizontal stretch or compression. If B equals 1, that is the same as your parent function, right? You don't see value there, you know it's 1, right? Coefficient, invisible coefficients are always 1. So no stretch, compression, in parent function. But if B is less than 1, there's a horizontal stretch. Okay, so the shorter B is, the further it's stretched out horizontally. It's kind of the opposite of what you would think. And the larger B is, there is a horizontal compression. So if B is greater than 1, there's a compression. Okay? All right. Very good. Number 4, explain and show how to find the amplitude of the function. You need your amplitude formula. If you need a reminder of what that is, amplitude is max minus min over 2. Because remember, let's say you have your function. Let's switch it up. Let's make it just a negative cosine function like this. They're saying the difference from here to there, that will give you this entire distance. This doing this. And then you divide it by 2 because that cuts this in half, and we know amplitude is the distance from the mid to the max. So that's just a quick explanation of why the amplitude equation is what it is. And we need to do a few things here. Well, you actually didn't need the period formula because they showed you what, or sorry, the amplitude formula because they showed you what the amplitude is. But keep in mind, this is not -5. Amplitude is a distance from mid to max. This is a negative sine function, so the y-intercept would be the midline and we would go down. So the amplitude is from here to here. Okay? That is a distance. It must be positive. That's why I use absolute value. And remember, the negative just means it's a reflection, meaning the positive sine function started going up, so it would look like that. But we're dealing with a negative sine function, so it is reflected, right? Think of this x-axis as a mirror. Two more problems today. You're doing great. Let's keep practicing. Explain and show how to find the equation of the midline for the function here. Well, this is quite possibly the easiest question. Number 1 was pretty simple too, but it's all about what you see at the end, right? Let me get a different color here. It's all about what you see right here. That's the vertical shift, which is also the midline, right? Moving up or down. If it's negative, we're moving down, right? So if m is -1, then the equation of the midline is y equals -1. So I know this can sometimes be confusing because you're thinking M and Y. Well, yes. Here we're saying M midline, M in our function, I should say, is -1. But if you're writing the equation of the midline itself to graph it, this is how you write it. And last but not least, number 6, explain and show how to find the frequency of the function. Frequency is something you do or don't see in the function. Because we see amplitude, we see midline, and we see B, but we don't see F. How do we find it? Well, to find F, you need a few equations. We know that frequency is the reciprocal of period, but we don't see the period in the function either, do we? What do we see? We see B, right? That's what this value is, but B does not involve X. So if you see X over 3, that's the same as 1x over 3 or 1/3 x. So B is 1/3. Okay, B is 1/3, and we need that right here in our period formula. So we plug in 1/3. We have a complex fraction here, so we want to keep, change, flip to get the period. And as always, frequency is the reciprocal of period. So if period is 6 pi over 1, frequency is 1 over 6 pi. So your answer, they want to know the frequency. There it is. Come back to get the rest of this review, because that's it for now.